Moments acting on a uniform rod. Now, uniform rod is a really key word here. If it says uniform rod in the question, it means the centre of mass or weight is in the centre of the rod. And that will be very helpful for this question. So, let's read this question. A uniform rod, AB, of length 4 metres and weight 20 newtons, is suspended horizontally by 2 vertical strings attached at A and at B. A particle of weight 10 newtons is attached to the rod at point C, where AC is 1.5 metres. Find the magnitudes of the tensions in the strings. Now, it's also important when answering questions involving moments, it's important to check whether you're given the weights or the masses. In this question, we're given the weights. If you're given the masses, you need to remember to do your mass times gravity to get the weight, because we're looking at the forces. Remember, moments are found by doing the force times the perpendicular distance. So if you're given the mass, you must do mass times gravity. But in this question, we're given the weight, so we don't need to worry about that. So, let's underline the key words in the question. So, the rod is of length 4 metres. It's also pretty important that it's a uniform rod. We know there's a weight of 20 newtons for the rod, and it's attached at 2 vertical strings at A and B. And there's a particle of 10 newtons at point C, which is 1.5 metres away from A. Now, with moments, it's really, really important you draw a nice, clear diagram for yourself. So, start off with your rod, which we know the distance of the rod is 4 metres. And it's at A and B. Now, we're told there's 2 vertical strings here. So, there's 1 and there's 2. And from this, there's going to be a tension, a T1 and a T2. We're also told it's a uniform rod. So remember, that means the weight is acting in the middle, and the weight is 20 newtons. So 20 newtons acting down. Now, it's also going to be useful to know the distance from A to the centre. Well, if it's 4 metres all the way across, half of it is going to be 2 metres. And also, we're told that at point C, which is 1.5 metres from A, there's a weight of 10 newtons acting down. And that's all the key points from the question in a diagram. Now, I like to write down all the distances I know. You need to decide for yourself how many distances you want to write down, because for some people they find it confusing to write everything down. I prefer to write all the distance down. Okay, now we can assume that this rod is sat there in equilibrium. So that means that the force is acting upwards, so the tensions must add up to the forces acting downwards. So this means that the T1 add the T2 must be equal to 10 plus 20, because the T1 and T2 are the forces acting upwards and the 10 and 20 are acting downwards. So that means T1 plus T2 is equal to 30 newtons. That is going to be important in a minute. Firstly, we want to find out one of either T1 or T2. Now, the only way to do that is to find moments about either A or about B. Because if you find moments about A, so this one, you're going to get rid of T1, because the perpendicular distance between A and T1 is 0, and 0 times anything is 0. So we will eliminate T1. So let's do that. So let's find moments about A. So moments about A. Now, it's important in the exam to let your examiner know, but that's what you're doing. Right, next step is we need to highlight which of our three forces we're going to be looking at is acting clockwise and which ones are acting anti-clockwise. So, clockwise is going to be the 10 and the 20, and the anti-clockwise is going to be the T2. Right, when solving a question like this, you need to find the clockwise momentums and the anti-clockwise momentums, and they're going to be equal to each other because there's no turning effect here. So, the clockwise moments are equal to the anti-clockwise moments. So, the anti-clockwise moments equal to the clockwise moments. So, let's do this. So, the clockwise moments are the 10 and the 20, and the anti-clockwise is the T2. So, first step, the distance between A and T2 is 4 metres. So, it's 4 times T2 equals 10 times that distance, which is 1.5. So 10 times 1.5 plus the other moment clockwise, which is 20 times 2 metres. So 20 times 2. We tidy this up. We get 4 times T2 is equal to 15 plus 40, which, if we sort out again, becomes 4T2 equals 55. So T2 is equal to 13.75 newtons. So we now know the tension in T2, and earlier on we wrote down an equation which was T1 plus T2 equals 30 newtons. So if we know T2, which is 13.75, we can now find T1. So, last step is sub T2 into T1 plus T2 equals 30. So, here we go. So, T1 plus 13.75 is equal to 30. And if you rearrange that by taking away 13.75, you get T1 is equal to 16.25 newtons. So we found the tension in both T1 and in T2.